homework. Let's see who got their homework done here. Oh, computer's running slow this morning. Having trouble waking up. Okay, here we go. Oh, I got to transfer. Kendall, did you have all your homework done up to this point? Okay. It's just easier than having to go back and transfer grades. Okay. Website's done? Website's done? Website's done? Good. Oh, that's nice. All right, here we go. First hour. Shay, did you get any of your stuff caught up over the weekend? In your packet there? Oh, or did you have it done last week and I just didn't know about it? Okay, that's fine. Okay. All right, we got that updated. I just wanted to get that all updated for you. Okay, so any questions on anything from the homework? Did you have an opportunity to double check your work with the answer key that I provided online? Alex, did you do your homework?
Yeah.
The one question that we had from first hour was about this guy here. Okay, remember when you make sulfurous gas or sulfurous acid where you have your hydrogen and your SO3 coming together, you automatically erase that and put these two things in its place. And that's down at the bottom of your solubility chart to help you remember how to do that. Okay, so if you didn't get that done, I can guarantee on the test that there's going to be one like that. That one or the carbonate one. One version has one and the other version has the other. So, you know, I can't just do one version of the test. We got to do at least two. At least. Sometimes there's one. Questions on anything on the homework? Anything you want me to go through for you? Yes, ma'am.
You just like we run through under 10.
10. Okay. Let's run over to here and grab number 10 here. All right, so here I have, well, let me pull it up over here so that I can talk you through it. So number 10's here. All right, let me get my marker. Where did I put my marker? Oh, right where it's supposed to be. That's surprising. All right, so I have silver acetate. So silver is Ag, acetate is C2H3O2. That's a polyatomic ion. This has a +1 charge. This is a -1. So we're set with our charges. I can move on to potassium chromate. The potassium chromate is K2CrO4. This was a +1. This was a -2. So I've got to have 2 of these for every one of these. All right, my cations are going to stay. My anions are going to swap partners. So this is going to get the chromate. And the silver, yeah, I did that. My potassium is going to go with my acetate. And those are both put +1s. So this one is already balanced. All right, so then we need to identify what is our solid and what is aqueous. So this is potassium. Almost all the time, potassium is going to be soluble, and almost all the time acetate is too. So we could check our sheet, but I can guarantee you that that's going to come in aqueous. Now, this guy doesn't appear on the front of the sheet, but if you flip over your solubility chart, I have a lot of hints and stuff back there. Look at number 9 on there. What does it say? Flip it over. There you go. What does number 9 say? Right. Chromates are frequently insoluble. So almost all the time, this is going to come in as a solid. And then you just need to balance this guy. So I need 2 of these. And then I'm going to have to get this side to balance, which I put 2 there, and I got it to balance. Did that help?
You do one that's like more like the balancing, because that's what kind of throws me off.
Okay. Get back over here. Okay, let's do number 3 then. All right, so here we have cadmium phosphate. So here's my CD, and my phosphate is PO4. This is a +2. I know that because they told me right here. Phosphate is a -3. So I've got to have 3 of these for every 2 of these. Then my ammonium sulfide. Ammonium is NH4. That's on my polyatomic ion sheet. Sulfide, it ends in "ide", so it's just the single element, sulfur. This is a +1. This is a -2. So I've got to have 2 of these for every 1 of these. Okay? All right, then I'm going to swap partners. So my cadmium is going to stay in place. My sulfur is going to come over to it. So it's going to bump this out, and then that's going to swap places with this guy. So then I go and I do my ammonium, which is NH4, and then I bring the phosphate over with that. This is a -1. This is a +3, or I'm sorry, this is a +1. This is a -3. So I've got to have 3 of these for every 1 of these. Then I'm going to check my solubility chart. When I do that, are you comfortable doing that? Okay. This guy is going to come in as a solid, and this guy is going to come in as aqueous, I believe. Yes? Okay. All right. So now I've got to get this to balance. So over here, and let me just take a second here, see if this will let me. Here, that's what I need to do. I can do, like, if you need extra space, you can always do this on a separate sheet of paper if you want. But when you do this, you can always go back and continue to do those kind of tables on here if you need. So this is my cadmium. My phosphate is the same on both sides, so I can keep it together. I've got my ammonia, and I've got my sulfur. Okay, now I'm going to do my inventory. I've got 3 of these. I have 2 of these, because remember, it's what's outside the parentheses, or if there's no parentheses, then you just have 1. So I've got 2 of these. I have 2 of these, and I have 1 of these. So over here, I've got 1 and 1. Here I have 3 and 1. You good with those inventories? Okay. So now I'm going to look at this and go, oh, I've got over here, I've got an even number of phosphates. Over here, I have an odd. Over here, I have an odd. And over here, I have got an even. So even and odd, what do? What is the rule? Double the odd. So these are both odds. I'm going to double both of them by doing that. So now I've got a 2 here for this guy, but I've got 6 because 2 times 3 is 6. Then I need to get some of this other stuff to line up. So I'm going to go back over here and I'm going to try to get my ammonia to get to 6. So I'm going to go back over here. I need to get this guy to get to a 6. So I'm going to put a 3 there. So that gives me 6 of him. My sulfur, though, it gives me 3. Now, I need to get this guy and this guy to 3. So I put a 3 there. And that gets those to balance. Does that help? Do you want me to do another one? Okay. All right. So calcium hydroxide is Ca. And this is going to be OH2. This was a +2. This was a -1. So I needed 2 of those to balance out this +2 here. Phosphoric. There is oxygen here because it doesn't start with hydro. So I'm going to change the ic back to an 8. And I'm going to find out what phosphate is. So phosphate is PO4. It has a -3 charge. And it's an acid, so it's going to start with a hydrogen with a +1. So I need 3 of these for every one of these. My calcium is going to stay where it's at, and the phosphate is going to come over with it. +2 - 3, so I need 3 of these, and I need 2 of those. Then my H is going to go with my OH, and sometimes it's just easier to write it as HOH. Again, if you get into college, I would probably erase that when I'm done balancing it and write it back as H2O. Okay? But for me, I'm fine with it. AP, you really don't have to balance much in there because they expect you already to know how to do that. All right. So now I'm going to do my inventories. I've got calcium here. I have hydroxide. I have a hydrogen. And I have a phosphate. Is it Ben again?
No, that's Andrew.
Andrew.
Okay, I've got 2 of these. I've got 3 of these. I've got 1 of these. Over here, I've got 3. I got 1, 1, and my phosphate, I've got 2. You good with that? Okay. So now I'm looking, I'm going, I got to get some stuff to balance out here. What am I going to do? My calcium, I've got to have that up to 3. So I'm going to start by putting a 3 there. That not only affects my calcium, it also affects my hydroxide. So that takes that up to 6. Then I've got to get my PO4s to balance. So over here, I'm going to put a 2 because this was 2, 1, and 2. So I'm going to put a 2. That gets this guy off. And then this guy gets up to a 2. So now if I go back over, see how those both say 6? All I have to do is put a 6 there, and then I got it to balance. That makes sense? It's easy when I do it, right? Yeah, I know. There's a lot going on, but, you know, I mean, really, you're taking, you know, all the way back to the beginning of December, you know, stuff that we learned back at the beginning of December and going all the way through. I mean, we've learned a lot in that past, you know, month and a half. So you've got to apply a lot of stuff to just a couple problems. And yeah, I know that's why we practice, and do more practice. All right. So let's look at the notes for today. And what you're going to have in here on Wednesday is you're going to have a quiz similar to this. All right. Now, this quiz is the same idea as the formulas quiz, where you can do it several times until we either run out of time or you run out of quizzes. Okay, I think I've got 4 or 5 attempts at it made up. So you got plenty of tries at the whole thing. All right. I got to turn on comments here so that it'll let me write. So when we're doing these, the first thing that you need to do is you need to identify what type of reaction it is, because now everything's kind of jumbled. We're not saying, oh, these are all single replacements or these are all double replacements. You've got to figure out by just looking at the reactants what it is. Okay? So I'm going to give you some kind of contextual clues here, like be able to look at it and be able to go, oh, that's this, or oh, that's that. Yes.
Okay, I got the right sheet. What did I do? It looks like English.
Okay, so when I went in to get my copies, one of the English teachers was in there copying stuff, and she'd taken my stuff off the copy machine. I think that she must have taken an extra copy of hers. And she's a newer one, so I don't even know who to get it back to. All right. So when I look at this, I see silver oxide and water. I'm like, I don't know. But remember, you've got your sheet. So start going through your sheet if you don't know what it is right away. And look at that. Letter B on synthesis. Do you see it? What does it say? Metallic oxide. Well, guess what? This is a metal. That's an oxide. So metallic oxide and water, that's going to be a synthesis problem. Okay. And we'll come back and do these all together. I just want to identify them first, and then we'll come back and balance them in just a minute or two. Okay. All right. This guy, anytime that you have one of these hydrocarbons, see how it has hydrogen and carbon? That's called a hydrocarbon. That is going to automatically be a combustion reaction. So you can kind of go down here. There's several of them on here. You can go ahead and write in combustion for all of those. All right. So anytime you see a hydrocarbon problem, you know automatically, boom, it's combustion. Easy enough to kind of scale that down and figure that out. All right, so let's identify the rest of these. Here we have an element and we have a compound. When you have an element and a compound, this is automatically a single replacement. Maybe. I'm going to put a question mark there. Why is it a question mark?
Because couldn't it be non-reactive?
Exactly. Okay. So I'm putting a question mark there because I've got to go back and I've got to check my table to make sure that it's single replacement. It may be no reaction. If that lead is less reactive than the hydrogen, it's not going to replace it. Okay. So we're still like, we're up in the air, but we know at least where we need to go on here to figure it out. Okay. Make sense? All right. So let's keep chugging along here. Element, compound. What is that? Single replacement. Yes, exactly. Single replacement. Because we're not sure yet. We've got to check. Okay. All right. This should be easy. Is there a plus sign anywhere here? No. If there's no plus sign, there is only one option that this could possibly be. And what is that? Decomposition. Because there's nothing to synthesize. There's nothing here to synthesize and make anything with. There's nothing here to bump something else out. It has to be decomposition because there's nothing else there. There's no oxygen. It's obviously not combustion. Okay. So the only thing that leaves is decomposition. All right. Next one, compound. single element. So what is this? Yes, single replacement. And then we're like, maybe, because we got to check. This is a compound and an element. And we're already telling you, because this, like I said, like if it's not a halogen, we have to check our chart, but the oxygen isn't on our chart. So oxygen, we're telling you, is more reactive than carbon. So we know that this is what? Or not more reactive than chlorine. I'm sorry. So we know automatically this is what? Single replacement. Yeah. And we don't need a question mark because we've already done the checking. It's right here. We know that that oxygen is going to go in and bump that chlorine out of the way. All right, last one then is rubidium and water. Rubidium is an element, and this is a compound. So when we have a single element and a compound, it is single replacement. Okay, so we're going to go back and do some checking. All right. Are you getting a feeling for how to kind of, when you were just given a list, how to figure out what type it is? It's going to take practice. It will. I'm telling you guys, this will not come like that to all of you. Okay. But over time, the more practice you do, the better it's going to work. Okay. All right. So let's go back up and start balancing some of these. So I've got silver oxide. So that's Ag2O plus water. We identified that as a synthesis problem. So I'm going to go to my sheet and I'm going to find this example, which is letter B on my sheet. Letter B tells me that I form a metal oxide. So my metal is Ag, my oxide is oxygen. This is a +1 and a -2. No, metal hydroxide, right? Metal hydroxide. Okay, get it right, Lippy. Sorry, you should have seen me first hour. I was really off first hour. All right, so metal hydroxide is here. I need 2 of these for for this guy, so that balances out. So if I do my inventories again, Ag, O, and H. Ag is 2. Oxygens, I've got 2 over here, and hydrogens, I have 2. So over here, I need 2 of everything. Right now, I've got 1. So if I put a big 2 there, then that balances all of that out. All right, the next one is a little bit of a bear. Try to get some of this stuff off of here so that you can see. I don't know that I gave myself quite enough room to write. I apologize for any of those of you who are still working on this one. All right, so we've got C5H9 plus, oh my gosh. Yep, I told you it's a Monday. It's feeling like a Monday, isn't it? H9. Oh my God, I did it again. There. I'll just use the eraser and get it right. Plus O2 yields CO2 plus H2O. Now, when you do this, use your reaction type sheet, okay? On here, we have this written out for you. We have a sample problem written out. It says O2 there, okay? So look at this so that you make sure that you write down your O2 because you don't want to forget that that's a Brinkelhoff. You'll get it marked wrong. All right, So when I do this, I'm going to tell you straight off, this was a bugger of a problem first hour. We're actually going to have to put a 4 here. And I'm not going to give you anything this hard on a test or quiz. So I'm just going to start this one out. This is kind of mean, actually. All right. So this is going to be 20. So I need 20 carbons. This is going to be 36 hydrogens. Half of 36 is 18. So then I do my oxygens. I've got 40 oxygens here because 20 times 2 is 40, plus the 18 here. And that's going to equal 58. So I need 58 over here. I got to put a 29 down. That one was a bear. I don't like that one. I should change that one. But I've already printed the sheets. So, yeah, here's that. All right, here we go. This one, we've got to figure out if it's going to run. So I've got my lead. I've got phosphoric acid. So phosphoric, this doesn't have hydro in it. So I know that it's going to have oxygen in it. I need to change the ic to 8. All acids start with H, and then I need to look up phosphate. So this is a -3. This is a +1. So I'm going to have 3 of these for every one of these. Then I need to check my sheet. This is a cation. Okay. Is lead more reactive than hydrogen?
Yeah.
So it appears higher up on the sheet than hydrogen. 1 higher, but that's fine. It's still better. So that means that hydrogen's going to go sit on the bench. But remember, hydrogen's a Brinkelhoff. So it's going on the bench. And my lead is going to go into the game. Now, over here, where we gave you this 2, that 2 doesn't indicate that it's a Brinkelhoff. Okay, so don't let that fool you. The reason why we gave you this charge is so that you would know what to do over here. So that you know that this was a +2 and this guy's a -3. So don't let this kind of throw you in that process. I need 3 of these and I need 2 of these. All right, now I'm going to do my inventories. So I've got my lead, I've got my hydrogen, and I have my phosphate. One, 3, 1, 3, 2, and 2. All right. So when I do that, I've got to get this to balance. I'm not going to attack my lead or my hydrogen right away because those are singletons here and here. What I'm going to do is I'm going to start in on my phosphate. So I see on this side that I've got 2 here. I've got 1 here. So I need to get 2 on this side. If I put a 2 there, that'll take that guy up to 2, but it also affects my hydrogen. Then I need to work on getting my hydrogen and my lead balanced. So my lead over here, I need a 3. My hydrogen, I need 6 over here. So again, I need a 3. Is that working out? Okay. All right, next one is combustion. So see if you can get that one started. We've already done one, so you should be able to write down the products for that guy and see if you can get started balancing it. So take a second or two to do that. I got to clear off some of this stuff that I've done. Clean it up a little bit. There we go. That should stay on a little better. All right, let's get this cleared up. Okay. All right, so let's get started here. We've got C8H16 plus O2, CO2 plus H2O. All right, now my trick was even and odd, or if this is an even number, we're going to put a 2 out here. So I'm going to put 16 carbon here, and then I need a 16 for my hydrogen. No, yes, that's right. Yep. And then I've got to figure out my oxygen. So I've got 32 here plus 16. That's a total of 48. And this ends up being 24. Now, remember when I said at the end of this, you need to go back and look to see if anything's divisible by 2? This is a case where that is going to happen, okay? So everything's divisible by 2. This guy's going to go away. This guy's going to become a 12. This guy is going to become 8. And this guy is going to become 8. So my little trick doesn't work 100% of the time. Okay? You've got to go back and kind of reevaluate. But I would say 95% of the time it works. But I wanted to show you a couple problems on here where it doesn't, just so you can kind of see that. All right. Does this make sense as far as balancing? Balance your carbon, balance your hydrogen, balance your oxygen. All right. The next one we need to check out. So lead, we're trying to see if that's going to replace iron. Is lead a better player than iron? No. So what you need to do here is erase this and write in NR. And that's it. That's all you have to do. You don't have to write anything else down. Okay? So don't spend your time trying to balance something that's not going to run anyway. Okay? Just write NR, drop the mic, walk away. All right, next one is decomp. So this one is sodium carbonate. And on my reaction type sheet, when I look at that, it tells me that I am going to have which option on here? A through F, which option is it? D, yep, metallic carbonate. And what does that make? Metallic oxide. What's my metal? Sodium. So sodium oxide. And it's also going to make CO2 gas. Now, I need to go back and reevaluate my oxidation numbers here. This is a +1. This is a -2. So I got to have 2 of these for every one of these. Remember, do not grab subscripts and bring them over. It will not work. All right, now we need to balance. I got 2 sodiums. My carbons, I have 1. And my oxygens, I have 2, 3. So I've got 3. So this guy's already balanced for us. See if you can do number 7. See if it's going to run first, and then see if you can get that done. Oh, Alex, I'm sorry, honey.
I was already balanced because we had CO3 and CO2.
Well, if I do an inventory, I've got sodium, I've got carbon, and I've got oxygen. So over here, I've got 2 sodiums, I've got 1 carbon, and I have 3 oxygens. Over here, I've got 2 sodiums, I have 1 carbon, and I've got 1 oxygen here, plus 2 from here. That makes 3. Yeah. All right, so we've got silver nitrate, NO3, and I've got copper. Now, I'm not going to write this 2 down for the copper. That's just there to help us on the other side if we need it. I need to see if copper is more reactive than silver, and indeed it is, which means silver is going to go sit on the bench. And we're going to get copper to go over here with the nitrate. Okay? Did you get that for your starting amounts before you have to balance? Then I've got to balance this guy, so I'm going to put a 2 here and a 2 here, and that should get it to balance. All right, questions on that guy? Anybody? Does that work out okay for you? Okay. So let's look at the next one. I'm going to do some erasing here, clear up some spots. I feel like I talk with my hands as much as I talk with my pen here. Or my pen as much as I talk with my hands. I'm most always going all over the place with stuff. All right, so let's look at this next guy. We've got a combustion reaction. Remember, our combustion reactions always result in CO2 and H2O. So I'm going to start by balancing my carbon. Then I'm going to balance my hydrogens, and then I'm going to go back and balance my oxygens. Oh, this is not going to work. I'm going to have to go back and double this guy, because otherwise my oxygens here are going to be an odd number, and I'm never going to get it to balance on this side. So I'm going to go back and do a little bit of work here. I'm going to go back, and I'm going to double this guy. That gives me 6. Oh, shoot. Wrong spot. 6 here. And then I need to put a 6 here for this guy. Then I'm going to add up my oxygens. So I've got 12 here. And I've got 6 here. That is a total of 18. So I put a 9 there. All right. MoCl6 plus O2. And we've got to figure out, they told us that oxygen is more reactive, which means chlorine's going to go sit on the bench. Oxygen's going to go in the game. So this is a +6 and a -2. So I need 3 of these for every 1 of these. Then I'm going to go and balance this guy. My oxygens here, I'm going to have to put a 2 here to get that to balance, which means I need a 6 here. Am I doing this right? No, I don't need a 6 there. I need a 3 there. No. 2, yeah. No. Oh, this is what I did wrong. Remember, sometimes when you yeah. I had my formula wrong. I need 3 of these. There we go. Now that's going to work out much better. That's why I was like, there's something wrong here. Okay. So if you write your formula wrong, sometimes these things will never balance. And that was a good case of where I was going to screw that up. You think this is bad? You should have seen me first hour. My brain was all over the place. All right. So let's go back. We've got 6 oxygens, so I need to get 6 oxygens. My chlorines, I'm going to have to go back over here. I've got to get a 2 here to get my MOs to balance. And then that makes this guy a 6 to get him to balance. There we go. Better? Okay. Student approved. All right, last one we're going to work through. Oh, do I just have 1 minute? No, I've got 4 minutes, 3 minutes. Okay, I got enough time. So this is that call out box up here. Okay, this is a metal and water. So anytime you've got a single element and water, this call out box is going to be where you want to go. Okay. So where is rubidium in that call out box? They don't list it specifically. Where is it at? Where's rubidium on the periodic table? Right, it's an alkali metal. It's in column 1. So this is an alkali plus water. So rubidium plus water. And that's going to give us what? Metal hydroxide. So that's OH plus hydrogen gas. So now we need to get this to balance. I have a rubidium, I have hydrogen, and I have oxygen. So I've got 1 of these, 2 of these, and 1 of these. 3 and 1. Go. So it looks like my hydrogen is going to be my bugger. So I've got to figure out, well, over here, this hydrogen is the one that's causing problems because he's the odd one, isn't he? And remember, I can't multiply anything by anything else if to be able to get an odd number, but I can to get this to be an even number. So I'm going to put a 2 here. That's going to give me 2 rubidium. It's going to give me 2 oxygen, and it's going to give me 4 hydrogens. So going back over here, To get the hydrogens to balance, I'm going to put a 2. And that raises that up to 2. So that's balanced. And then if I put a 2 there, I've got that. Okay. Homework tonight is 9.5. It's pretty much just the same as this. Remember, the answer key is online. Here's how I want you to do that. Okay. When you do your homework tonight, I want you to pretend that it's a quiz. Okay. So go through and see how you do, and then go back to the answer key and get that to help you out. Okay. Don't just speed through it and go, good enough. Go back and spend some time with that answer key, and then come back tomorrow with questions. Okay. All right. Today may be a 3 cup of coffee day.
What?
3 cup of coffee instead of 2.
So,
Oh. Bye, y'all. Have a good night. That's kind of exhausting.
You do the same thing every class like that?
I do this 3 times, AP of a lecture 2 times, so that's 5, and then regular chem we're going over. They're doing formulas again today. So I've got I do this 7 times.
Sounds like fun.
My voice is about shot by